going to be a 3-step process to calculate the height of your rocket's trajectory. Go to Clinometer Calculations, Schoology. If this screen is too small, you can always click on the title one more time and you get the bigger version. Only one student is in, so we'll wait for at least 4 or 5. 2. There's 4. All right. So physics students can use a clinometer, which is the protractor that's hanging upside down and a string is attached at 90 degrees with a straw as your telescope. You can follow the trajectory of a rocket. They measure the distance to the landing point of the rocket. So this example is 50 feet. I think for every team there was a different distance. So definitely change this number here when you are doing the calculations for the class. If the average height of a person's eye to the ground is 1.6 meters and the angle of the clinometer is 60, what is the height of the rocket's trajectory? Let me see if anyone needs paper to take notes. Anyone need paper? Okay. Paper and pencils are up here. Do you need a pencil? So what we're pretty much doing is the warm-up from yesterday when there was this scientist looking through a clinometer at the top of a building, and he used trigonometry to find x. Now some of you might not have taken trigonometry, or you don't remember it, or you've heard a little bit about it and haven't used it for real life purposes yet. So today will be the day you learn about trigonometry in real life scenarios. So the scientist is looking through the straw at the top of the building. The angle has been determined. The distance has been determined. The height of the clinometer has been determined. All of us are different heights, and some of us, myself included, I crouched a little bit to really get the angle of the trajectory. So my height, your height is not going to be consistent across the board. So we're just going to do the average height of a person's eye line to the ground, 1.6 meters, and for every problem. That way you don't have to get a string and measure how tall you are and then try to remember, did you crouch down or did you stand taller to get the rocket trajectory? 1.6 meters is going to be our distance from the ground and the clinometer. You have to add that to the distance of the rocket, the elevation of the rocket. So let me show you how this is done. Because if you add the height of the clinometer plus the height of the rocket, you'll get the total height of your trajectory. Let's start with this. So write this down. Tan theta, which is any angle, tan theta equals opposite over adjacent. How many ever heard of tan theta before in math? All right, see, not everybody. We've got about 5 or 6 students. Question, paper, scissors, tissue. There you go. Tan theta equals opposite over adjacent. What the heck does that mean? Well, if you think of real life as triangles, especially the trajectory of a rocket, there are different sides of the triangle that are labeled opposite and adjacent. And of course there's hypotenuse, but actually I think I'm going to delete hypotenuse because we're not going to even use it. So you have an adjacent side and an opposite side, and then you have an angle theta. This is just like the triangle in our scientist example. Technically, there's two triangles, but he just needs to find the triangle opposite side that is above the clinometer, and then he'll just add the height from underneath. So we're taking notes. Let's take some notes, put our phones away, charge our pouch, lock your pouch, and we're going to calculate the height of a rocket. Your rocket and your classmate's rocket. Once we find the tan theta and the adjacent, we can multiply those together and find the side that's called opposite. So let's find theta first. This word problem says the angle was 60 on the clinometer. But if you did the warm-up, you can't use the exact degree that's in the clinometer because you have to subtract 90 from it. Remember, when the string is hanging from when it's perpendicular, it's at 90 degrees. So if you're going to really get the angle of the straw when it lifts, you have to subtract 90. Okay, I'll repeat that. When your straw's flat, in other words, the rocket has not launched, the string is hanging at 90. So what you have to do as a physics student is see how far the clinometer moves from 90. And so if this string moved to 60, we have to do 90 minus 60 every single time. So 90 minus 60 is the first calculation you need to make to find theta, to find the angle. 90 minus 60 is the first step. This is a 3-step problem. After you find your angle of the clinometer, the true angle of the clinometer, you have to convert your distance to meters. So rewrite distance. Here, let's do this. Distance of the rocket. You're going to start with 50 feet, and then we'll convert it to meters. So 50 feet. Ignore the red part for now. And then you need a conversion factor where 1 meter equals 3.28 feet. I don't expect you to know that. I even had to look it up because it's a specific number. But when you multiply this to a conversion factor, because 1 meter and 3.28 feet are the same value, in other words, it's 1 over 1. In other words, it's just multiplying by 1. You can cancel out your like terms. So we did this maybe 3 weeks ago when we converted kilometers per hour to meters per second. But this is just one unit that we're converting. So cancel out your feet, and you get the value 50 meters over 3.28. And when you divide that, you get a value. So let me pass off these calculators. So the next hands-on activity is to build a helicopter. That'll be after another 2 weeks of math calculation. We're going to divide 50 by 3.28. Let's call on a student. More. What did you get when you take 50 divided by 328? So put in 50, 50, divided by 328. Grab a calculator, follow along. $50 divided by 328. Try one more time. 50 divided by 328. Yeah, it should be on your screen, or you can look at my screen if you're able to see. Like, yeah, try to follow along. Everyone on the notes? Good. Join us. You're on Clinometer Calculations. Clinometer Calculations. 24, and these are meters. So you're doing the same thing, class, when you have your data sheet out. Now what do we do with this? We're going to plug it into our formula. Tangent theta equals opposite over adjacent. So let's start scooting these down. All right. Tan 30, we found it here, equals opposite, which is just one of the sides of the triangle, over 15.24. That's what the Moore found for us. Now, how do we get rid of this? How do we solve for opposite? Let's ask Bradley. What steps should we take to get opposite by itself? It's kind of showing a little bit. Give me a good guess. By what number? 15.24. Right? So just rewrite that, and the tangent on your calculator might be very new to you. So first write your times 15.24 multiplication. Then click the button tan. It's right next to the division symbol. Everyone click tan. Everyone put in 30, but then you have to put an end parentheses. Otherwise, it's not going to do things in order. So you should see tan parentheses 30 end parentheses. And then you can hit multiply 15.24. Let's ask Xavier, what do you get when you do tan 30 end parentheses times 15.24? 8.8. 8.8. Now this is the opposite side of the triangle of the eye level and up. We have to add the average height of the person's eye level to this number. So the last step is to add 1.6, the average height of a person's eye line, to the ground with 8.80. And let's ask someone who's here. Elijah, what is 1.6 times 8.8? Sorry, plus 8.8. 1.6 plus 8.8. Average height of a human's eye line to the ground, and the launch of the rocket, 10.4 meters. And that's how you... I heard 10.4. Did you say 3.4? Yeah. Add them. Add them together. 1.6 plus 8.8 is 10.4. So this is what you'll do 11 times today, because you're going to find the height of your team and your classmates' teams using your data chart.